Alright, so let's look at the derivatives of inverse functions, right? So inverse function, what do we mean by inverse function? We mean sine, okay, sorry, let me change this to a brush. I keep forgetting. So that means we mean sine inverse, we mean cos inverse, we have tan inverse, cosec inverse, and the likes, right? That's what we mean by inverse function, right? When you see that -1, then yes, we are talking about inverse functions. So now, very quickly, we have question 1. We have y is equal to the sine inverse of x. So now let me point out something. Now, when we have something like sine x is equal to 0.5, and then we want to find the value of x, what do? We say x is equal to the sine inverse of 0.5. So we can apply this same idea to this one. Yeah, so we're going to say here that this thing was gotten from sine y is equal to x. Do you agree with me? Because when we want to find y now, we just take the sine inverse of x, which is what we have here. So now we have this. What are we going to do now? X is on its own. So now let us find the derivative of both sides. Remember, when you find the derivative of y, you add the y dx, right? So the derivative of sine y is going to be cos y, right? It's going to be cos y, and then you're going to add our dy dx, and the derivative of x is what? Just 1. It's just 1. So now we're going to divide both sides by cos y. So we have the y over the x is equal to 1 over cos y. But this is our answer, but we cannot leave it like this, right? Because the options will not be in this form. But basically, this is our answer. We have to change this cos y to a form that has at least x in it. To a form that has at least x in it. So, right? So now let's do this, because now we already know that sine y is equal to x. So how can we change cos y to look like sine y? Very quickly, from trig identities, we know that cos square y plus sine square y is equal to 1. The reason why I'm using y is because we have y here. If it was x, I'll use x, right? It does not matter the letter, just that the two letters that are used for cos and y, cos and sine must be the same thing, right? So cos square y plus sine square y is equal to 1. So very quickly, let's make cos square y the subject of the relation. So we have cos square y is equal to 1 minus sine square y. Here we can take the square root of both sides so that we have just cos y. So cos y, the square here will cancel the square root. So cos y is equal to root 1 minus sine square y. Here we cannot cancel any square because this is not a perfect it is not a perfect square. So we cannot cancel out. So this is what we're just going to have. So very quickly now, here we have sine square y, but we know that here that sine y is equal to x. So we're going to say cos y is equal to the root of 1 minus x squared, right? 1 minus x squared, because here we have sine y, sine square y. Sine square y is basically sine y times sine y, right? And since y, sine y is x, we have x times x, and that will be equal to x squared. So that means 1 minus x. So that means cos y is equal to 1 minus x squared, and we can put it here. So now we are going to have dy over dx is equal to 1 over root 1 minus x squared. Very, very simple. So now you can see that our answer has x, and it makes more sense than just leaving it as cos y. This is what you will see in the options, and you're good to go. Very, very simple. Derivative of inverse function is nothing to stress about. Just know that you have to change the form. So you change it, and then you find the derivative of both sides, and then you solve. So let's go for question 2 now. You can pause the video and try it out. So for question 2, we have y is equal to cos inverse of x. So very quickly, this is going to be cos y is equal to x. Take the derivative of both sides. When you derive cos y, you get what? Minus sine y. Since we are finding the derivative of y, we're going to add dy dx, and this is going to be equal to 1. This is going to be equal to 1. So we have dy over dx is equal to 1 over minus sine y. Right? So now let us use our trig identities again. So we have cos square y plus sine square y is equal to 1. So here we'll make sine square y subject of the relation. So we have 1 minus cos square y. And then we have sine y is equal to the root of 1 minus cos square y. And now cos y is what? That's x, right? So we're going to say sine y is equal to the root of 1 minus x squared. So here we're going to say dy over dx is equal to 1 over minus root of 1 minus x squared. So this is going to be our final answer for that question. So now let's go for question 3, which is tan inverse of x. You can pause the video to try it out yourself. Tan inverse of x, and then we have question 3. So y is equal to the tan inverse of x. So here we're going to say tan y is equal to x. Take the derivative of both sides. When we derive tan, we get sec square y. Then we're going to add the y dx, and this is going to be equal to 1. So the y over dx is equal to 1 over sec square y. Now, according to trig functions, we have tan square y is equal to 1 plus sec square y. So that means sec square y is equal to tan square y minus 1, right? And tan y is equal to x, so that means we have sec square y is equal to x squared minus 1. So we're just going to say dy dx equals to 1 over x squared minus 1. Very simple. Then we have question 4. Question 4, I'm going to do that very quickly now. We have question 4, which says y is the sine inverse of x squared. So now we have y to be equal to the sine inverse of x squared. You can pause the video to try this out yourself. So let us go. So we have sine y is equal to x squared. Take the derivative of both sides. We have cos y dy dx is equal to 2x. Then we have dy over dx is equal to 2x over cos y. Remember, we already said that cos y is equal to the root of 1 minus 1 minus x squared that we got before, but this time around we're having x squared here, so we have to actually define it. We cannot just say this is going to be cos y, because this time around sin y is equal to x squared and not just x, as in the case for the first question. So we have cos square y is equal to 1 minus sine square y. Then we have cos y is equal to the root of 1 minus sine square y. And here we're going to have the root of 1 minus, now sine square y. Since sine y is equal to x squared, sine square y is equal to sine y times sine y, and this is going to be x squared times x squared, and that's going to be x to the power of 4. So this will be 1 minus x to the power of 4, and then we'll just put 2x over our root 1 minus x to the power of 4. And this is our final answer, and that is it for the